Okay, in this lesson we're going to talk about how to multiply radicals, and radical is just a generic term for something that's either a square root or a cube root or a fourth root or some kind of root. And so when you're multiplying radicals, you can multiply them and put them both under the same radical as long as they both had the same root. So in this case, there's a square root times another square root. So we can put both of these under the same square root because they're equivalent to each other. The roots are equivalent. So then it becomes 21. In this case, you have a cube root of 7 and a cube root of x. So since they're both cube roots, you can just combine them under the same cube root house, you can think of it. All right, so let's talk about how to simplify radicals. All right, they're only considered simplified if all the factors that can be brought out of the radical are actually brought out. So if something can come out, it needs to be out. So when you look at what's under the radical, you start using your factor tree. And you might have thought of a different set of factors, but in the end, would all get the same answer. That's okay. So I thought of 3 times 100. Well, that doesn't give me any pairs. I'm looking for a set of 2. Ooh, but I found a set of 2 tens. So I can pull one of my tens out. This does not have any further factors that we could find a set of 2, so it stays under the radical. Similarly, I did the same thing here with the number. The x cannot be factored out in any way, so he's going to end up staying under the radical. The y can be factored into 2 y's, so one of the y's is pulled out. The 10 is pulled out because it's part of the set of 2, but the 5 doesn't have a partner, so he has to stay under the radical. Okay, I did one more example here where it was a little bit more complicated. Again, I'm looking for sets of 2 because this is a square root. So I factored the x's out and I got a set of 2x squares, and there's an x left over. When I factored the y's out, I started thinking, hey, I noticed that there's going to be 6 sets of 2 here. So I don't have to write them all out if I know that there's going to be 6 sets of 2 to give me 12. So I know that there's 6 sets of y, so I'm going to need 6 y's. One of the y's is left under the radical. Here I did the same thing with the z. There's 3 sets of 2. Okay, so z to the 6th is like a z. Z, 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 z. Okay, so there's a set of 2, a set of 2, and a set of 2. So each of those, that gives me z cubed. There's a z that's left under the radical. Let's do a little bit more. Now we have a cube root. So what does that mean? We're looking for sets of 3. So 32, I start factoring it out. I found a set of 3, and then there's a 4 left. So the 2 comes out, and the 4 stays under the cube root. Now I start working with the x. I'm looking for a set of 3. So I have x times x times x, which is a set. X times x times x, which is a set of 3. So I have 2 sets of 3. Okay, remember for each set of 3 of something, you pull 1 out. So you had a set of 3, so I'm pulling 1 out, and another set of 3, and I pulled another out. Okay, and then over here, I have a whole bunch of sets of 3 here. There's 5 sets of 3, and then there's a y left over, if you can think of it that way, like y times y times y, y times y times y, and so forth. So you pull out one of these y's, one of these, one of these, one of these, one of these. So you end up pulling out 5. Now, let's combine like terms. Since this is a cube root, and this is a cube root, and this is a cube root, we can put all of them under the same cube root. 2 is multiplied times x squared, which is multiplied by y to the 5th, so we just put all that part together. Now, if you want to think of it as a fractional exponent, you could do that. So this x to the 8th and to the 3rd root, it's the same thing as saying x to the 8th power and the 3rd root. So if you know how to write mixed fractions, you can say, oh, I have x to the 2 and 2/3. So I have x squared, and I have a 2/3, which this is x 2/3. 2 is the power, 3rd is the root. And it turns into this. Similarly, y is raised to the 16th power. It's helpful to use the fractions when you have larger numbers because you don't really want to write all these out. It's kind of cumbersome, but it's fine if you do. It just takes a little longer. So 16 divided by 3 is going to be 5 wholes, and then there's going to be a third left over. Well, y to the 1/3 is the same as 1 is to the power, 3 is to the root. Okay, so then you end up with 1 is to the power, and then 3 is to the root, and y to the 5th. All right, so I wanted you to try these, but I showed you the answer. And I took each part separately and factored each part out. I wanted to point out that in each of these cases, something was left without a fifth, a partner, okay? Because we're looking for sets of 5 here since it's a 5th root. The 2 has to stay under here. The x cubed, well, I only got 3 x's, so there's no way to get a set of 5. So I just left it under the radical. I got 2 y's left over. That's not going to help me, so it has to stay under the radicals because I'm looking for sets of 5. And then the z to the 4th is going to stay under the radical. Otherwise, I found full sets that I could pull out of the radical.